Well, hello there, guys, gals. Welcome to Steve's garage. Yep, this is my garage here at the house, and it's where I hang out a lot. And so, I want to make a video for you guys today, show you some stuff about continuing our study on electrical things, electrical systems, diagnostics, and so forth. You know, in class we've been talking about a particular schematic and blower motor system, and it looks like this. We've been talking about schematics and reading schematics, and this is the one for the blower motor on a 99 Cavalier, and we've talked about some of the different parts and how it's labeled and what all that stuff means. And so what I want to do today is make a little bit of a transition from the page to the actual parts. And so what I have behind me here is a project board that I put together some time ago, and went to one of my favorite parts, and that's places, that's pull apart. Got some parts off of a Cavalier, put them on the board here, put it all together in a working fashion so that we can look at this, and hopefully we can learn a little bit more about about electricity and how it works. But really, one of the things I want us to see, and I think sometimes it's hard for us to grasp sometimes, is the connection between what's on the page and then what's actually on the car. So that's really kind of what I want to focus on here, and a little bit of testing and so forth, and a little bit of diagnosis, show you a few things. But so that's what we want to do today. Again, welcome, and hope this will be beneficial. So what I'm going to do now is I'm going to take this camera off of the stand, give you a close-up view of some of these parts, and talk a little bit more about them. Okay? Here we go. Turn this screen around. All right, here we go. Okay, so what we're going to do today, here's kind of our outline for today. Basic electrical, Chevrolet J-car, blower circuit. Compare the schematic to the actual parts, and we're going to have a little worksheet for you there too, as you've got to take some notes on. So we're going to look at fuses, grounds, relays, bus bars, splices, and a little bit about testing, okay? So as with all things electrical, it starts with the battery. So I have a battery here, and I have a battery charger connected to it just so that it stays charged while we're doing our testing, okay? So the cables come right over to the board. The positive cable comes right up to the fuse blocks here, okay? Connects right here to the fuse block, all right? Provides power for all of that. Then our ground comes right from the battery, comes right over to this ground strap that I have. I put this ground strap all the way across the bottom here, so for testing and for grounding our parts with, okay? Because to have a complete circuit, right, we've got to get everything back to the battery on the ground side. Okay, so we have our fuse, underhood fuse and relay center right here, okay? And our 30 amp fuse, this blower fuse, is right here on this system. Our blower relay, is the bottom one down here, and our relay box, fuse box, has a cover, shows us all that. So the big fuses there are like ignition, battery 2, ABS, cooling fans, but our blower fuse at the top left there, and then our relays go down. Our bottom relay says heater blower. Okay, so it's labeled on the fuse box cover, so we know which one is which here. Okay. So our blower fuse is hot all the time, it says on our schematic. So let's see if it is. We've got our test light connected to ground right there, and we can touch it right there and we see it lights up. So our blower fuse, according to our schematic, is hot all the time, and sure enough, it's hot. Got power to it. Okay. All right, that's good. So let's come over here to the ignition switch. Now technically the ignition switch is not on the schematic, but does play a role in distributing voltage and power throughout the car. Okay, so we have a positive lead coming off the fuse box here through a splice right here. Here's a basic splice. It's a factory splice where they've spliced two wires together. They went from one wire to two wires. So a splice is simply a connection between two circuits to make them act as one. Okay, so we spliced it off into two, and it goes into two separate spots there on this switch. Okay, so that splice, this is hot all the time too. Okay, see there, it's hot all the time. So our orange wire that goes back to feed our relays and stuff here for our blower is only hot in the run position. Our yellow wire right here is actually our crank wire. If we turn the switch to the crank position, then this wire gets hot, and it's only hot during cranking. So that's how the ignition switch works. It's just switching voltage between different circuits to power up things on the car. Okay? All right, so next is our control assembly, our heater, AC, and rear defogger control assembly. This is the part that we see on the dash, right? So we got our blower controls right here, our temperature controls right here, and then our mode and on-off switch right here, and our AC switch and so forth. Okay, so our ignition switch was already in the run position. When I turned it on, you see we got power there, and our fan came on low speed. All right, you can hear it running. So here's our blower resistor. Okay, it's on your schematic too. It says blower resistor, and there's 4 wires going to it, right? And your schematic says that they are tan, blue, orange, and black and white. All right, so that's what we've got right there. Then our blower motor, of course, is right here. I've got a lead hooked up to the connector, but here's our blower motor right here. We come around to the back side of this, we can see it. See it running right here. Feel the air coming off of it. You can also see our blower resistor board right here and the fan. So let's go ahead and turn it up. There's the next speed. Next speed. Full speed. All right. Works just fine. So that's what it's supposed to do, right? Got all the speeds, blower motor works. Everybody's happy. Everybody happy? All right. All right, so let's turn this on. So we've got our multimeter here, and we've got our black and our common, and our red and our volt ohm diode testing position, and we put it on DC volts so we can check some things here. So I have the positive lead into the supply side of the blower motor. Because the purple wire is hot whenever the system is turned on. We have power to the blower motor all the time in that respect. Then the other side is ground, but I did not have my meter to ground right here. So our system voltage on your worksheet is 3.88 volts. 13.88 volts. And the reason it's 13 volts is because I have the battery charger over there on the battery, and it's on a supply voltage. So it holds at about 13 volts, 13.8. Okay, so that's our system voltage for our test. It's 13.8. All right, so that's some of the parts. Okay, again, we have our ground straps down here, our ground for our relay, our ground for our switch and control here, and then we have this splice here. On our schematic, the orange wire from the blower resistor to the blower has a splice in it, and this is representing that right here. That is splice S125. Okay, you see that on your schematic? S125, or 124, I'm sorry. S124 is right here. Okay? All right. The brown wire over here is S125, is this splice right here that I've spliced together. You can see it. Yeah, it goes to our control there. Okay, so what else do we have there? That's just about it on parts. We've got the battery, which is our power supply, fuses, which are our power supply, our controls right here. So our controls, another part of our controls, our load and our ground and our insulated wire. Okay, that's all 6 parts of the circuit. Remember, there's only 6 parts to a DC circuit. All right, they may look a little different on different cars, but really, the more we think about how those are just all 6 parts and what each one of them is doing and is supposed to do, it really helps us in our diagnosis. and understanding how these work. Okay? All right. Now for a little treat, I'm going to show you something else in my garage. I told you guys that I collect die-cast cars. And so I'm going to show you what I got up here on the shelf. You can see it. Yeah, there's my Texaco there. That's my 50 Chevy or 50 Camaro truck with some Camaros on it. Camaros in the garage there. And over here I've got some more muscle cars in a garage, and a guy there drinking a Coke machine, some cars. Yeah, then I've got another Gulf station over here with some Mopars in it, sitting there. Yeah, how about that? So, some of my car collection here, just for the fun of it there, thought I'd show that while we was here. All right, so let's put this back on the stand here, do a little testing. Try not to shake it too much. And let's hook the power back up so we don't lose the battery. Okay. Here we go. Okay, so that's some of our parts. And again, what we're doing is just showing the connection or the relationship between the schematic and the actual parts and how they work. So let's talk a little bit about testing a little bit, okay? Testing. To test for ground, how do we test for ground, okay? Let's back up just a little bit. What is the definition of ground? Okay, so ground, by definition, is the point of lowest voltage on a circuit, okay? Lowest voltage on a circuit is how it's defined. But we can use a test light to check for that, and we can use a voltmeter to test for that, okay? So, as we've already learned, light bulbs don't really care which way the voltage goes. Okay, you can light a light bulb, a DC light bulb, either direction. So if we want to check for ground and use a test light, we can do that. If we connect to the positive terminal of the battery, okay, we hook to the positive terminal of the battery, and we put our test light on the ground, it lights up, right? That's how we check for ground. That's one way we check for ground. Okay, so we've got ground there, we've got ground on our bar, of course, ground on our terminals here. Okay, that's one way to check for ground. That works pretty good. It's one of the easiest ways to check for ground. All right. Another way is with, well, that's really one of the best ways to check. And you can also check it with an ohm meter, and we'll do that another time, another place. But an ohm meter works pretty good too. But a test light really works well because it actually puts a little bit of a load on the ground, and you can check and make sure it's working. Okay, so let's talk about the blower motor. Turn that off for a second. So let's talk about testing for a blower motor inoperative. Okay, so there's going to be a diagnostic chart for that, and it's going to take you down through a bunch of steps. But if you've got a schematic and you understand how the system works, it's a lot quicker just to do it that way with a schematic. Okay, so let's show you something here. Forgive me for turning my back to the camera, but I have to here a little bit. All right. So let's unplug the blower motor, and let's hook a test light to the connection there. So the blower motor only has two wires going to it, right? Power and ground. So a lot of components on a vehicle are that way, power and ground. And what I've got here is a test light that I made. Actually, this came off a brand new Colorado truck recently, and it is a tail lamp harness. Okay, so we got turn signals, park lights, backup light, turn signal, backup light, and running lights, tail lights, and turn signals, and brake lights, all in one harness. And so what I've done there is I've got the ground side of the connector, and then I've got the power side of all the bulbs. Okay, and they did the rest of the splicing for me on the connectors there. You can see. Okay, so it's just two wires, makes the bulbs come on. So if a customer came in and he said the blower motor didn't work at all, right? First thing I do is I get my schematic, just make sure what everything is. And then I unplug the blower motor because it's usually pretty easy to get to underneath the dash. And I plug in my test light. Okay? plug in my test light. Hold it up here so you can see. So this way we can check every part of the circuit really. We're going to turn it on. You see this, they're just barely glowing here right now. You can see that. All right. So that's good. That means we got power, means we got ground, means our switch worked. Let's turn it up to the next setting. Got a little brighter. Turn it up to the next setting. Got a lot brighter. And the next one gets even brighter. So what we've done there in that simple test takes what? 15 seconds. We've tested the switch, we've tested the fuse, we've checked the relay, we've checked the wiring, we've checked everything up to the blower motor, and it all works like it's supposed to. Okay? So let's just say, for example's sake though, that while we were turning our switch up here, that position 2 went off. There wasn't anything there. Okay? But then position 3 worked and position 4 worked. Then we'd have more likely have a bad switch right here. Okay? Yeah. So, it's a real simple test, very easy to do. Alright, and then unplug that. So, if all that works like it's supposed to at our connector, but the blower motor still doesn't work, then yeah, the blower motor's bad. Okay? And if you want to, you can go ahead and jumper 12 volts to it. You know, I have in my toolbox some connectors like this that I can plug right into the blower motor and substitute, you know, power and ground to it. Just make sure it doesn't work that way. But if you checked it like this and the blower motor doesn't work, then it needs a new blower motor. Okay? Pretty simple test. Pretty easy to do. Okay, let's plug this back in. Another thing that I wanted to show you while I had this hooked up is a little bit about voltage drop. Okay? And we're going to talk more in class about what that is and why it is like that. But I want to show you how it actually looks on this blower motor system. Okay? So let me hook this up for us real quick. Okay, I'm going to take this camera off here so you can see the voltmeter. Okay. So what I've got here is I've got the meter hooked up across the 2 leads. Can you see that? The red on the power and the black on the ground. And we've got it operating. So let's just go ahead and turn it off. So with it off, we have no voltage there right now because the system's turned off. All right. Now remember, our source voltage was 1388. Okay. So we're going to turn it on, and we're on low speed. So write this down on your worksheet. Okay. Low speed voltage drop reading is 5 volts, 5.0, and fluctuates a little bit. Low speed, or position number 1. Okay? Position number 2, we now have 7.6, almost 7.7 volts. Okay? Position 3, we now have 10.5 volts. Position 4, 12.6. Okay, so a little bit about what's happening there. As we change the speed and as the voltage goes through the blower motor and the resistors, we have more than one load. Okay, and as we look at our schematic, we know that the resistor here has three resistors in it, not 4, 3 resistors in it. And on high speed, it bypasses all of those resistors, and we got straight voltage. On all the other positions, it has one or more excuse me, resistors that are also taking some of the power. Okay, so that's all we'll say about that right now. We'll talk more about that in class live. Okay, but I wanted you to see this and how it actually looks. It's a good demonstration of voltage drop and what's happening. All right. Okay, let's put the camera back on stand. All right. Okay, there's one other thing I need to show you. This has to do with the bus. Talked about a B plus bus or a battery voltage bus, and this is another fuse box just like the one on the board. So I've got another one to show, and so I want to show you this right here on the back side of this. This is where the battery cable attaches, and this is a positive bus right here. This metal bar right here is a bus. Well, that bus goes to all these fuses on this side of these fuses. The fuse plugs right in to that terminal on this bus bar. Then we have the fuse. Then on the other side of the fuse is these red wires right here. So here's the one coming in, okay, on that side, connects to the bus, and all these fuses, all these wires right here come out and go to other components. And what did they go to? Let's look. Okay. Get my cover here. They went to ignition circuit, a battery circuit, battery 2 circuit, analog brake system, and it went to the cooling fans. Okay, so that's how they separate or distribute is the word they use, is power distribution. That's how power gets distributed throughout the car, is a lot of times by a bus. Okay, so there's some other buses in here that are just a little bit harder to see. This one's pretty easy to see out here like this. Okay, so you can have a positive bus and you can have a negative bus where a bunch of ground wires are connected together. Okay, so that was one of the other components I wanted you to see. Okay, so we have talked about all the parts to the blower. We've talked about fuses a little bit, or circuit protection, about grounds, blower relay is right here. If we unplug it, the blower quits. Okay, the standard 4-terminal relay, we'll talk more about that in class and how those work. Talked about bus bars or power distribution. Talked about splices, different places here, what those look like, a little bit about ground, blower test. Okay, so I hope that was helpful for you to see that. It's a lot of fun building these things and working with them and testing them and looking at them. I enjoy doing that. Thanks for visiting my garage with me today, and so we'll take some questions now and talk some more about these type of things, dealing with electrical circuits. All right, thank you.